Hello, this is Phil Thomas, New Era Systems. Going to do a couple of things today. On the left you can see a datum PSM 4900 modem. This is one of the old style legacy 70 megahertz modems. And to the right you can see another old style piece of equipment. This is an 8-watt Anacom transceiver. It's got to be something of a challenge today because I haven't looked at one of these datum 4900s for many years. And so I have to fight my way through the menu system. Shouldn't be too difficult, but it's always a challenge. Now, I said this Anacom unit was a transceiver, so what exactly is a transceiver? We used to use these before we used BUCs because they combine two different elements. They have the conversion from 70 megahertz to, in this case, KU-Band, but also through something that Anacom call an LNC. Today we have LNAs and LNBs. This is very much the same sort of thing. That straps right onto the antenna. It takes the KU-Band RF signal and it passes it back to the Anacom transceiver. The Anacom transceiver then down converts it back into 70 megahertz IF. This unit is a receiver, a transmitter, an up converter and a down converter. One of the things that I'm never fond of with Anacom is this set of, I'm going to call them cooling fins, I don't know what else they are, but they get so dirty. But fortunately we have this very special cleaning tool imported at great cost all the way from the Orient. Wrap a little piece of rag on the end of this and you can clean out these fins. Some people call them chopsticks, but anyway. Now what else have we got on here? This is where we connect the LNC. This is the LNC, connects from there to there, and this other side goes onto the receive port of the antenna. This is connected to the 70 megahertz transmit side of the modem. So the modem transmits 70 megahertz to here. This in turn up converts it and passes it out through the transmit port here. This mess here is simply a way for me to test safely. This is called a cross-guide coupler. I connect this to my power meter or to my spectrum analyzer. The fin part on top absorbs the RF signal that this transceiver is generating. This port takes the down converted signal back to the modem. Now again, it started out as KU. It has been converted within this transceiver. It's now heading back to the modem as an IF signal. Over here we have two different M&C ports. I tend to use the RS-232, which I connect to my very old computer that has the most blessed of all things, a serial port. So with that connection, I'm going to use Anacom's piece of software that they call the VSAT supervisor. I'll be able to look at the settings on the transceiver, make sure everything's okay, and then we'll be able to start the test. So it'll take me a few minutes now to get everything set up. Before completing the connections, I decided I'd have a look at this modem, figure out how everything works. And it seems pretty straightforward. Over here we have different buttons for different functions. For example, I'm going to look at modulation. What I really want to do with this modem is to set it up generating a pure carrier, 70 megahertz, somewhere in the middle of the power range. So I'm going to look at modulator. Well, we come up immediately with modulator test. Okay, in normal. So it's going to put out a normal modulated carrier, which I don't particularly want. So I'm going to go to edit, probably up or down arrow. Let's try down. There it is, pure carrier. Now I presume enter to save it. Okay, let's see what else we can get in here because I want to find okay. It appears that we're still in test, so let's go to the right arrow and see what we get. Status. Okay, it's telling us that its test is active simply because that pure carrier has been set up. Okay, I'm not really interested in status. I'm going to go to the right again. Okay, here we are, IF. This is probably what we need. Minus 35 is a pretty high attenuation, in other words, low power, which is fine. Let's go down and see what else we can do in IF. Output is enabled, okay. Modulation, QPSK. Just out of curiosity, let's see what our other choices are. We go to enter, down, BPSK, okay, just QPSK or BPSK. We're going to stay with QPSK and we're going to say enter there. Keep on down through the IF menu, normal spectrum, AUPC disabled, well, that's fine. IF mute automatic, don't know what that's used for. Impedance 75 ohms, good. And frequency, well, here's the frequency set at 70 meg, which is what I want again. So let's see what else we have. Offset, I don't need an offset. And so we're back to the beginning again. So what we know so far, on the modulator side, it's set up to show that it's in test mode. In other words, it's going to be that pure carrier. There are no other alarms. On the DMOD side, yes, there's a major alarm, most likely because it's not getting any input. If it was receiving a modulated carrier, this is good enough for the modem. I know that I've got it output in 70 meg. So now I'm going to go ahead and set up the transceiver that I discussed a few minutes ago. Now we're looking at Anacom's monitor screen. We're connected by serial cable to this transceiver, and you see there's a problem. And it looks as if it's in the power supply. You can see over here, let me get my handy Oriental cleaning tool. 12 volt is showing low. The 5 volt is showing low too. And that has turned the TX, it does flip the TX on. Flipping the TX on has caused the transceiver to shut down and restart again. So this is the good thing about Anacom's supervisor program. It points to a problem. Okay, now it's come back up and we're seeing a good 12 volts on here. Nope, it's flipping backwards and forwards. This transceiver is obviously a basket case, so I'm going to disconnect all of this, put it on the basket case shelf and pull out another one. We'll continue with this test with another 8-watt Anacom transceiver. I'm ready to start another test on an 8-watt Anacom. One failed yesterday. I now have a suspicion why it failed, and I'm going to examine that later. But first let's run over the equipment we have here. Bottom of the screen on the left is a data modem set up to generate a pure carrier at 70 megahertz to that transceiver. I'm going to monitor the output, the power on the HP Agilent power meter on top, and the frequency on the spectrum analyzer below. I'll be using Anacom's Supervisor 7 software initially just to look at the transceiver, see what the power levels are, see what the voltage levels are, and do an initial setup. But most of the control is going to be done via the modem. Now let's bring up the supervisor. Okay, it's looking around to see if it can see a unit. Yes, it does. And we see a couple of things on here. Obviously the transmitter is turned off, and that's good. The output is shown at 14.25, kind of in the middle of the KU-Band range. The TX gain is down, and that's where I want to leave it because I'm going to control the output on the modem and not on this. Now with everything else, let's just check out and see what we've got. 12 volt is showing us good, the fan is good. It's a tad low, but I don't think it'll make any difference, that 5 volt supply. Now I happen to know that the modem transmitter is turned off, so now it's safe for me to turn the transmit on here. And now I'm going to go back to the modem and I'm going to control the output of this transceiver from there. Now on the modem, I'm looking at the IF menu settings. Currently the output level is minus 22 dBm. That's okay, it's moderately low. We'll see how it holds up on the spectrum analyzer and power meter once we turn the transmit on. So first thing I'm going to do is go to the transmit. Frequency is 70 megahertz, fine. Impedance we don't care about. What I'm looking for now is the IF output. There it is. So I go to Edit, Enable, Enter. Now on the spectrum analyzer, you see that you can see the CW signal and an output of 516 milliwatts. So it's not very much yet. So what I want to do now, I want to gradually increase the power here. Power level is shown at neg 22. I'm going to bring it down to about neg 20. And when I do that, I'm going to hit the increase button, because the increase actually reduces the attenuation. And now when I hit enter, you see a jump. We're still not up to 1 watt, so we're going to go down some more. This time I think I will take it there, negative 18. Now we're running at 1.4, nearly 1.5 watts. So I'm going to take it to negative 17 now and watch. Nope, I'll go straight to negative 16, I think. We're up in the 2.4. Looks as if we need to go down to somewhere around 12, 13. Now this would seem to be high for a modem, but don't forget we've turned the transmit level on the transceiver down using the Anacom software. So everything is being controlled through this modem now. Let's look at 13 and see what that does for us. Okay, we're up to 5. Don't forget the output of this unit should be about 8 watts. So again, let us go a couple of steps, minus 11, and see where that brings us. Now we just topped out. We've just gone out up over 8 to 8.4. That's as far as I'm going to go. Everything seems to be fine. Looking at the spectrum analyzer, the CW is looking nice and clean, right in the middle of the frequency range where it should be. So I'm quite confident that this transceiver is working well. Now normally before shipping I would go to the bottom end of the transmit range, run through these tests again, then go to the top end of the transmit range. In fact, do it in 3 places. At the moment we're just in the middle. So that's it for the moment. I'm going to wrap this up, and now I've got another Anacom. It's the C-band that I'm going to bring up for the next video.